Hello, viewers. In today's session, we are going to discuss two important problems from linear differential equations, right? So, in this session, we are going to solve these two important problems and we'll also find out the general solution and the particular solution of these two differential equations. So here the first equation is x dy is equal to 2x raised to 5 plus y dx, and we have to find the particular solution at this condition, that is when x is 1, y is equal to 1. And similarly the second equation is y dx is equal to 2y square plus x dy, and the condition is x is equal to 1 and y is equal to 1, right? So here we'll briefly see the concept of linear differential equations, and then we'll see how we can utilize the concept of linear differential equations to solve these two given problems, right? So let us take these problems one by one. So now we have the linear differential equations of two types. The first one is the dy over dx plus py is equal to q, and the second form is the dx over dy plus uh, px is equal to q, right? So here we have two types of linear differential equations. One is dy over dx plus py is equal to q, and here we have dx over dy plus px is equal to q, right? So here the p and q are the functions of x, right? So p is a function of x and q is also a function of x, and here p is a function of y and q is also a function of y, right? So what we do here uh, in this type of linear differential equation, we first find out the integrating factor, that is e raised to integral p dx, right? And in this form of linear differential equation, we'll also find out the integrating factor, that is e raised to integral p dy, right? And the solution of this linear differential equation is given by this expression, that is y into integrating factor is equal to integral q times integrating factor dx plus c, right, where c is the constant of integration. And when we have this type of linear differential equation, then the solution is given by x times integrating factor is equal to integral q times integrating factor, and here we have dy plus c, where c is the constant of integration, right? So here viewers, we have taken the two problems. The first one belongs to this type of linear differential equation, and the second problem it belongs to this type of linear differential equation, right? So by solving these two equations, we can understand the concept and how to solve these two kinds of linear differential equations, right? So let us start. So now here we have x dy is equal to 2x raised to 5 plus y dx. So what we will do, we'll take this dx in the denominator of dy. So we have x dy over dx is equal to 2x raised to 5 plus y, right? Now let us divide both sides by this quantity x. We have dy over dx is equal to 2x raised to 4, because 1x get cancelled here, and here we have y over x. Now taking y over x to the left hand side, we have dy over dx minus y over x is equal to 2x raised to 4. So now we can write dy over dx plus minus 1 over xy, and here we have 2x raised to 4, right? So now we can see that this equation is of this form. So here we have dy over dx, then plus py. P is our expression 1 over x, and q is 2 times x raised to 4. So we can see that p and q are the functions of x, right? Okay, so now let us find out the integrating factor. So the integrating factor is given by e raised to integral p dx. So here we have p as minus 1 over x dx. So this is e raised to negative of log x, right? Because the integral 1 over x dx is log of x, and here log of x is the natural log of x, right? So we can also use this notation, that is e raised to negative ln x, but we'll prefer this one. So now here we can write the integrating factor as e raised to log of x raised to minus 1. So taking this negative sign to the power of x, so that we can now write e raised to log of 1 over x, right? Now we have a famous expression here, that is e raised to log of p is given by p. So here we have e raised to log of 1 over x, that is equal to 1 over x. So p is 1 over x, right? So the integrating factor of this linear differential equation is 1 over x. So now the solution of this equation, or this equation, is given by this expression. So we have y times integrating factor is 1 over x. Then we have q is 2x raised to 4 multiplied by integrating factor. So we have 1 over x. Here we have dx plus c. C is the constant of integration. So now here x and x get cancelled. We have 2x cube dx plus c. So we have y over x 2 times the integral of x cube is x raised to 4 over 4 plus c. So 2 times 2 is 4. So now we have y over x is equal to x raised to 4 over 2 plus c. Now multiplying both sides by x, we have y is equal to x raised to 5 over 2 plus cx. So this is the general solution of this differential equation, because this solution, it carries the constant of integration. So now here we have the initial value conditions. So we have y of 1 is equal to 1. So it implies that when x is equal to 1, y is equal to 1. So we can find out the constant of integration by taking x is equal to 1 and y is equal to 1 in this solution, right? So we have 1, and then we have 1 raised to 5 over 2 plus c times 1. So this is 1 is equal to half plus c. So c is 1 minus half, that is half. So the constant of integration has the value half. So now taking c is equal to half in this equation, we have y is equal to x raised to 5 over 2 plus x over 2, right? So c is 1 over 2. So now we can write y is equal to x raised to 5 plus x over 2. So this is the particular solution of this differential equation when the boundary conditions are x is equal to 1 and y is equal to 1, right? So we can also write this solution as 2y is equal to x times x raised to 4 plus 1. So this is the solution of this differential equation. So now let us consider the second differential equation. So here we have y dx is equal to 2y square plus x dy, right? So now this equation is of this form. So let us rearrange the terms here. So we can now write taking this dy to the denominator of dx. So we have dx over dy is equal to 2y square plus x, and here we have y, right? Now dividing both sides by y, we can now have dx over dy. Here we have simply 2y because 1y get cancelled here, and here we have x over y. So now taking this term x over y to the left hand side, we have dx over dy minus x over y is equal to 2y. So we can now write dx over dy plus minus 1 over y, x and 2y. Now we can easily see that this differential equation, it resembles with this one. That is dx over dy. Then we have plus minus 1 over y, x. Px is equal to q, and we can see that p is minus 1 over y, q is 2y, and p and q both are functions of y. So now let us find out the integrating factor. So the integrating factor is given by e raised to integral p dy. So we have e raised to p is minus 1 over y dy. So this is e raised to minus 1 over y dy. This is e raised to minus log of y, because the integral 1 over y dy is log of y. This is natural log. So we can also write it as e raised to minus ln y. This is e raised to minus log of, we can write it like this, log of y raised to minus 1. So taking this negative 1 to the power of y here, now we can write e raised to log y raised to minus 1 as y raised to minus 1, which is equal to 1 over y, right? So here we have used this result, that is e raised to log of p is given by p. So now the integrating factor of this linear differential equation is 1 over y. So now substituting the values in this solution, we have the solution as x times integrating factor, which is 1 over y. Then we have integral q is 2y. Then we have integrating factor, that is 1 over y. Then we have dy plus c. C is the constant of integration. So we have x over y. This is y, and y get cancelled. We can take 2 outside the integral. So we have simply dy plus c. So now we have x over y. The integral dy is y. This is 2y plus c. So now we can write it as x is equal to 2y square. Multiplying 2y by y and c by y, we have cy, right? So this is the general solution of this differential equation, because this contains c, which is the constant of integration, right? So now we can find out the value of c by taking the conditions, that is y of 1 is equal to 1. It means when x is 1, y is 1. So taking x is equal to 1 and y is equal to 1 in this equation, we have 1, 2 times 1 square, c times 1. So we have 1 is equal to 2 plus c. So c is 1 minus 2 minus 1. So the constant of integration is minus 1. So now taking c is equal to minus 1 over here, the particular solution is given by x is equal to 2y square minus y, right? So this is the particular solution of this differential equation. So viewers, this is how we can solve these two types of linear differential equation of first order and first degree.